Now listen. Suppose consider a result. If x equals xn being a convergent sequence, suppose xn converges to x. Sequence xn, suppose sequence xn converges to x. Then what about a mod xn? Is it converges to mod x? That's an important question. If xn converges to mod x, if a sequence converges to a particular point, then what about the absolute value of that sequence? Can you say that the absolute value of that sequence converges to the absolute value of the point at which the original sequence converges? That's the question. Xn converges to x. Can you prove that mod xn converges to mod x? Xn converges to x means by definition it is for all epsilon is positive, there exists some k for an en such that mod xn, modulus of xn minus x strictly less than epsilon for all en greater than or equals k. K for an en. Okay. But we know that. What about modulus of mod xn minus mod x? We know that modulus of mod xn minus mod x less than or equals modulus of xn minus x. Okay, that's immediate. Modulus of mod xn minus mod x less than or equals mod xn minus x. But what is mod xn minus x? That is strictly less than epsilon for all n greater than or equals k under this condition. So finally, for all epsilon is positive, there exists a k for an n such that modulus of mod xn minus mod x is strictly less than epsilon for all n greater than or equals k. So you can say that from here mod xn minus mod x less than epsilon means mod xn converges to mod x. That is, when xn converges to x, then mod xn converges to mod x. Agreed? Okay. Now, come to another result. Here we prove that when xn converges to x, mod xn converges to mod x. Now suppose when xn converges to x, what about the root xn? This is our next question. Can you say that root xn converges to root x? That's a restriction. Here sequence xn be a sequence of non-negative terms, non-negative real numbers. Means sequence xn greater than or equals sequence of real numbers, and as xn converges to x, and can you say that root xn converges to root x? Here the restriction is xn is a sequence of non-negative reals. So how? So its proof is xn converges to x. Xn converges to x means for all epsilon is positive, there exists some k for an en such that modulus of xn minus x strictly less than some epsilon square. That's only for sake of argument. For all n greater than or equals k. Okay, right. And xn greater than or equals 0. Xn is a sequence of non-negative reals. When xn greater than or equals 0, then we know that limit xn also greater than or equals 0. This is a proved result. When xn greater than or equals 0, limit xn greater than or equals 0. What is limit xn? That is x. So limit xn greater than or equals 0 means x greater than or equals 0. Why? Because limit xn equals x. Xn converges to x. Clear? Okay. Now, case first. X equals 0. There are two possibilities. Either x equals 0 or x greater than 0. First possibility, x equals 0. When x equals 0, we know that xn converges to x. Xn converges to x means xn converges to s. What is x? X equals 0. So that means from here, for all epsilon is positive, there exists a k for an en such that modulus of xn minus 0 strictly less than epsilon or epsilon square for all n greater than or equals k. Okay, or epsilon, whatever may be. So that means modulus of xn strictly less than epsilon square for all n greater than or equals k. Mod xn less than epsilon square for all n greater than or equals. Now listen, what is xn? That's the sequence of non-negative reals. Since xn is a sequence of non-negative reals, modulus of xn means simply xn. So it is xn less than epsilon square for all n greater than or equals. Xn less than epsilon square means what is root xn? Root xn strictly less than epsilon for all n greater than or equals. Root xn less than epsilon means it is modulus of root xn minus 0 less than epsilon for all n greater than or equals. Okay, since xn is sequence of non-negative reals, root xn is also. So that means from here it is root xn converges to 0 for all n greater than or equals. Root xn converges to 0 means what is 0? 0 means root x. Why? So it is, yes, root xn minus 0 means root x equals 0, root x is also 0, so root xn converges to root x. So when x equals 0, the result is proved. Okay. Now the second case is when x is greater than 0. That is our second possibility. When x is greater than 0, what happens there? Case second, when x greater than 0. When x greater than 0, what's our aim? Root xn converges to root x. Consider root xn minus root x. Root xn minus root x can be rewritten as root xn minus root x into root xn plus root x all divided by root xn plus root x. That equals, it is xn minus x by root xn plus root x. But xn minus x by root xn plus root x strictly less than, it is xn minus x by root x. Why? Because secant xn is a positive sequence of or non-negative sequence of reals. So clearly xn minus x by root xn plus root x strictly less than xn minus x by root x. Okay. But we know that xn converges to x. When xn converges to x, then modulus of, but we know that xn converges to x. Xn converges to x means again for all epsilon is positive, there exists a k fall in n such that modulus of xn minus x strictly less than epsilon into root x. Why? Because root x is positive. Root x is positive. X greater than or equals 0. So root x is also non-negative. So it is mod xn minus x strictly less than epsilon into root x. Clear? Therefore, here xn minus, now consider modulus of root xn minus root x. Modulus of root xn minus root x strictly less than modulus of xn minus x by modulus of root x. Or epsilon into mod root x. Okay. So, what is mod xn minus x? So, it is strictly less than epsilon into modulus of root x divided by modulus of root x equals epsilon. That means modulus of root xn minus root x strictly less than epsilon. That means root xn converges to root x. So when x greater than 0, root xn also converges to root x. Clear? Okay. Thank you.